Hello friends, welcome to Getronics for you. In this video, we are going to discuss about the energy bond modeling of semiconductors. So let's begin. Modeling of semiconductors means this part. Modeling of semiconductors means such that the output of the model will be similar or analogous to the output of semiconductors. Then we can say that the model that we have developed is valid for the semiconductors. According to the syllabus of GATE, the semiconductors can be modeled in two ways. First one is the energy bond model. The second one is energy band model. These two models are completely different from each other, which will depicts the inner picture of a semiconductor. And for this case, we want to discuss about the energy bond model of a semiconductor. So for understanding the energy bond model, we need to understand some preliminary topics, such as the first one is the wave particle duality. Second one about the elastic wave. The third one is the bridge between the particle world and the wave world. And the fourth one is frequency and wavelength, that is lambda, related to smallest energy quanta. So these are the four topics that we need to understand first, then we can understand the energy bond model. So let us discuss first what is wave particle duality. Wave particle duality depicts that when an energy is propagates in the form of stream of particles and when matter propagates in the form of traveling waves. That means the scenario of the wave particle duality like is this. Suppose we have a matter. So suppose this is the matter A and it is at position 1. Now if the matter travels from position 1 to position 2, so the matter A has traveled from the position 1 to position 2. So physically the matter is moving. So according to the wave particle duality, we can see that the matter propagates in the form of traveling waves. That means there is a matter wave associated with this matter that is propagating along with the matter like this. So whenever a matter or a particle is moving from one point to another point, with that particle or matter, a wave associated with this matter is also moving from position 1 to position 2. Similarly, when a wave will propagate in this fashion, in this direction, from position 1 to position 2, then we can say that stream of particles are also moving with the waves. So we can say, तो मैं ये कह सकता हूँ कि कोई भी पार्टिकल और मैटर को मैं एक वेव के रूप में देख सकता हूँ. सिमिलरली और वाइस वर्सा कोई भी वेव और ट्रेवलिंग वेव को मैं स्ट्रीम ऑफ पार्टिकल्स का मूवमेंट के रूप में भी देख सकता हूँ. एंड वी विल यूज which one? It depends on the applications. For which applications I am using this wave particle duality concept, that will decide which one is to take. Now for electronics devices, we have to encounter with so many particles, and the particles are, first particle that we have to encounter is the electrons, second one is the photons, third one is the phonons, and the fourth one is the holes. These four particles will be produced inside the semiconductors. So since the particles are producing inside the semiconductor, that means there must be some energy that is producing inside the semiconductors. अगर कोई particles होगा semiconductors के अंदर, तो that means उसके साथ कोई traveling wave होंगे according to the wave particle duality. So let us see what are the traveling waves associated with these particles. We will make a chart of that, and in this chart, row wise, the first row will depict the name of the particle or stream of particle. What is the name of the particle stream? So as we know that we have first particle, that is photon, second particle is electron, and the third particle is phonon. In the second row, the traveling wave that will be associated with these particles. So for photon, the name of the traveling wave that will be associated with the photons according to the wave particle duality is the electromagnetic wave, and the traveling wave associated with the electron is the de Broglie wave, and the phonon will be associated with elastic wave. Since these are the traveling wave, so we can say some parameters will be there inside the wave of these waves which will vary with respect to position or time, because we know a traveling wave always have some parameter which will vary with respect to position and time always. So variables with respect to position x and time t. So what are the variables that are changing with respect to position and time of the traveling waves? For electromagnetic wave, the variables that will vary with respect to position x and time t is the electric field E and the magnetic field H. This electric field and the magnetic field of the electromagnetic wave will vary with respect to position and time. Now for the de Broglie wave, the probability parameter will vary with respect to position and time. But for the elastic wave, which is associated with the phonon particles, in this elastic wave, the atomic displacement will vary with respect to position and time. Now let us see what is the name of the wave. So name of wave equation for different particles. For photon, we know the traveling wave will be electromagnetic wave, and this electromagnetic wave can be defined by the Maxwell equation. Maxwell equation. Similarly, the de Broglie wave can be defined by Schrodinger's equation. Now for the elastic wave, there is not a single or specific equation. What does it mean? It does not mean that there is no equation related to the elastic wave. What it means that there are no single scientist or single equation related to the elastic wave. There are so many equations related to the elastic wave. That's why I put a dash here and write there are many equations. So this is all about the wave particle duality concept inside the semiconductors. Hopefully you have enjoyed the video. If you have enjoyed this video, please do give like and subscribe the channel and share as much as possible so that more students can be benefited. Thank you and keep watching Getronics for you.